I'm Alexander from RA, and today I want to show you the DiagRA S. What is it for and how you can set it up to simulate diagnostic communication with DiagRA D. First, I'm going to introduce DiagRA S. Then I show how to create a simulation project with DiagRA S. After that, I show how to add data for OPD communication from trace files. Then I show how to configure DiagRA D with DiagRA S for OPD communication. And finally, I show how to start simulation of diagnostic communication. DiagRA S is a new member of the DiagRA product family, which covers the simulation of diagnostic communication for single electronic control units and for whole vehicles. The DiagRA S is used for simulation of diagnostic capabilities of electronic control units. For example, you are developing or testing some diagnostic software, typically working with hardware interfaces based on one of the standards, DPDU API, ISO 22900 Part 2, pass-through, or RP 1210. This use case also includes development of OTX diagnostic sequences using any of the OTX authoring tools available on the market. To assure the high quality of your product during the whole product development cycle, you need to be able to test your diagnostic software in different situations. For example, different protocols, different ECUs, different responses, delayed responses, and etc. Your software might also need to be tested for handling of negative or missing responses from ECUs, unexpected data sent by ECUs, or possible misconfigurations of communication. And in optimal case, you want to assure the behavior of your diagnostic software by regression tests. Testing all of these different situations using hardware will require high efforts and high costs for preparing every test setup. Also, switching between different test setups will take long time, especially if many of the engineers and software developers are working in home office. What is the solution for this kind of problem? A pure software-based diagnostic simulator, our DiagRA S. Now I will show you how easy it is to configure DiagRA S for simulation of diagnostic communication, especially in case you already have a couple of diagnostic trace files. So let us start with DiagRA S. When you start DiagRA S, you see the home screen. In the main menu, you have some useful links to documentation, program settings, creation of support requests, as well as for selection of simulation file and directory with simulation files. The center part of the screen contains the short overview of the selected simulation project and the list of available simulation servers. Most of the simulation servers are started automatically upon the software start or selection of the corresponding simulation file. To create diagnostic simulation projects, DiagRA S delivers a separate tool called Data Manager. This tool allows creation, viewing, and editing of diagnostic simulation projects. Another very useful feature of this tool is the import of diagnostic communication trace files. If you have a diagnostic simulation project selected in DiagRA S, you are able to display its content in Data Manager by clicking on corresponding button in the main menu or in the toolbar. Let's create and use diagnostic simulation project in DiagRA S. We go to the main menu of DiagRA S and choose the menu item New Project. In the New Project dialog, we fill the project name, keep project type to be diagnostic project, and add some description. We are also able to choose the project location inside of the currently selected project directory. It helps us in an organization of our simulation projects. let's create a subfolder named OBD projects. We open the corresponding project directory in Windows Explorer and create the corresponding folder. Inside of the dialog, the folder tree is updated automatically, and we can select the newly created folder as target folder for our new project. In the bottom part of the dialog, it is possible to import diagnostic communication trace data to the new project. Let us skip this step and import log files later over Data Manager. By clicking on OK button, the diagnostic project is created and we are automatically navigated to the main view of Data Manager. As we can see in the quick overview for the newly created simulation project, its content is empty. Let us import some diagnostic communication trace files. There are various file formats supported, including ASC, DiagRA, and DiagRA D and SilverScan tool log files. We will import communication trace files produced by our world-leading legislated diagnostic software, SilverScan tool. We go to the main menu, Import log file. Then we select one .log file we want to import and click OK button. Few moments later, we see the import statistics for our import. This dialog shows some statistic data and also the errors and warnings occurred during the import. These errors are grouped per log file and per ECU. We finish the dialog and Data Manager displays the list of ECUs created from data in log files. Now let's have a quick look at the data. Let us select one of the ECUs in the tree view. The ECU has now an OBD diagnostic module created inside. Below OBD diagnostic module, there are nodes corresponding to OBD diagnostic services. Most of these services have also diagnostic objects defined for these services, for example DDCs, PIDs, and info types. By selecting the diagnostic object in the tree view, on the right side we will get the series of diagnostic object parameter data displayed for it. Every response in the table on the right side corresponds to one consequent diagnostic request for this diagnostic object. As we can see, the data is imported. I select the newly created project from the project list in DiagRA S. Now DiagRA S is configured and prepared for simulation of OBD communication. Let us start and configure DiagRA D for diagnostic communication with DiagRA S. I have just started DiagRA D. I go to the Scan Tool tab and select ISO 15765 Part 4 communication. As next, I select the DiagRA S pass-through interface for the communication in DiagRA D interface list. Now we are ready to start the diagnostic communication with DiagRA S. For DiagRA D, the results seen in the tool are the same as can be achieved with the real vehicle or ECU. It is possible to see all data from all OBD modes, request data cyclically, and clear DTC list as well. On DiagRA S side, we will see some activity in the main view for J2534 simulation server. Its state is changed to online and diagnostic tester is determined as DiagRA D application. In the bottom part of the window, we see the diagnostic trace for currently selected simulation server. We can observe that DiagRA D sends many CAN frames and we can trace the whole communication on DiagRA S side. It is important to note that DiagRA S brings not only the implementation of pass-through API, but also the implementation of other standardized interfaces like RP1210 and DPDO API. So the same simulation works also with these interfaces too. As all of these interfaces are standardized, any other diagnostic tool compliant with these standards will be able to simulate diagnostic communication using DiagRA S. As an example, we are testing our products like Silver Scan Tool, DiagRA Embedded, DiagRA LE, and Emotive Open Test Framework with DiagRA S. Great! Let's summarize our today's tutorial. I created a simulation project with DiagRA S. I added the simulation data for OBD communication from trace files recorded by Silver Scan Tool. I configured DiagRA D for OBD communication with DiagRA S and started the simulation of diagnostic communication. That's it for this video. I hope you enjoyed it. Take care of yourself, thanks for watching this video, and see you in the next video.